Hello everybody, this is Frank. Right now I can't get a haircut, so I thought I'd wear a hat. And Miss Jennifer asked me to wear it upside down backwards. So anyway, that's why I'm here. Hope you're doing well today. Today I'm going to talk to you about the trigonometric ratios. Whether you've had them or not, I'm not sure, but this could be your first introduction to them. So what I have is the basic concept of your trigonometric ratios, and then we're going to work probably about 8 or 9 examples, all the same, and then at the conclusion of this, I'm going to do 2 more questions, which I consider a little extra, and that should begin your study of trigonometric ratios. So, what we have today is a picture of a right triangle. Notice the right angle. And I've labeled one of the angles capital A. Now, there's 3 sides in a right triangle. It's a leg, and this is the hypotenuse. And sometimes I feel like students aren't always finding the hypotenuse correct. The hypotenuse is always across from the 90-degree angle, even if the triangle's turned. So go straight across, and that's your hypotenuse. Now, there's 2 more sides called legs, but now we're going to give them other names. Angle A, if you go straight across from angle A, that's called the opposite. Straight across. Now, adjacent means side by side. Well, what sides are adjacent to A? This side, but this is already called the hypotenuse. So this side is called the adjacent. So our definition of our trigonometric ratios are going to be based on this. So here's the angle. Straight across from it is the opposite. Touching it is the adjacent, and across from the right angle is the hypotenuse. Now, I'm going to give you 3 definitions of trig functions. Trigonometric functions, there's 6 of them, and we'll learn our 3 basic ones today. The first one is called the sine of the angle. Some call it the sin. It's called the sine. The proper word is S-I-N-E, but on the calculator keys in the books it'll be sine. The sine is defined to be the opposite divided by the hypotenuse. The opposite divided by the hypotenuse is the sine. So you need to find a way to memorize that. There's a lot of different sayings out there that could help you. The second one is what's called the cosine, which is COS. The cosine is defined to be the adjacent side divided by the hypotenuse. And then the third one is called the tangent. Abbreviated TAN, and it's mathematically defined as the opposite over the adjacent. Okay, now you have to find a way to memorize that. Once again, there's expressions. There's one called Sohcahtoa, which you may like. It's abbreviated SOH. That stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So spend a little time trying to learn ways to memorize it. Again, the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. And if this expression Sohcahtoa helps you, use it. So now we're going to use these three definitions on the problems. So let's go to our first one. Okay, we're going to use our definitions to work these problems. So what I'm going to do is write SOH CAH TOA up there as a reference. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay, so here we go. Let's look at the first one. Now, just so you know, all these triangles satisfy the Pythagorean theorem, which means leg squared plus leg squared is hypotenuse squared. So they all satisfy the Pythagorean relationship. Now, let's look at our first example. The sine of z. So put your finger on z. Now look at the definition. It's the opposite. So what side's opposite z? It's 21. And what's the hypotenuse? It's 35. Let's do that again. Sine is the opposite, 21, over the hypotenuse, 35. And it would be nice to reduce. 7 goes into both numbers, 3/5. And that's it. Let's look at the cosine. Cosine is defined to be the adjacent. Okay, what side is touching this angle Z? It's the 28, because this is already called the hypotenuse. So it's 28 divided by the hypotenuse of 35, which they're both divisible by 7, reduces to 4/5. And the tangent. The tangent is defined to be the opposite, 21, over the hypotenuse, 35. I'm sorry, it's the opposite over the adjacent of 28, which reduces to 3/4. So we're done with our first example. So I hope you're looking at that expression, Sohcahtoa, if that's going to help you and you're applying it. So let's go to the second example. And let's do it again. Look for the angle C, right there. Sine is the opposite, 28, over the hypotenuse, 35, which reduces by 7s to 4 over 5. Cosine is the adjacent, right there, touching it, over the hypotenuse, which reduces again by 7s, 3 to 5. And last is the tangent. It's the opposite divided by the adjacent, which is 4 over 3. So there's our 3 trigonometric ratios. Third example, and I find a lot of students sometimes don't find the right angle. This is the right angle. So that side there is the hypotenuse. That's the hypotenuse. So for the sine, we're looking at angle A. So what's the angle side opposite A? 16. And what's the hypotenuse? 34. So let's do that again. The sine is the opposite 16 over the hypotenuse of 34. And dividing by 2 gives us 8 over 17. The cosine is the adjacent side. Well, what side's touching A? It's this one. So it's 30 over 34, which reduces by 2s, of 15 over 17. And last, the tangent. The tangent of A is the opposite over the adjacent, which reduces by 2s, 8/15. So there's your 3 trigonometric ratios. Okay. And we continue. Example 4. Look for side Z, angle Z. It's up here. So what side is opposite Z? To 24. And what's the hypotenuse? To 40. And then reduce it by 8s. 8 goes into 24, 3, and 8 goes into 45. The cosine of Z is the adjacent side. That's this one. It's touching it. 32 over the hypotenuse, 40, and reduce it by 8s. 8 goes into 32, 4, and 8 goes into 45. And the tangent. The tangent is the opposite divided by the adjacent and divide by 8s, and you get 3 over 4. So there's our 3 trigonometric ratios. we go to the next example. It's repetitious, but that's how we learn. The sine of z, look for angle z, it's up here. The sine is the opposite. Over the hypotenuse. And we divide by 8, or 6, we reduce by 6s, and get 3/5. The cosine. Look at angle z. The cosine is the adjacent. That's this side. 24 over the hypotenuse, 30. And we reduce by 8s, or 6s in this case, 6s. 6 goes into this 4, 6 goes 5. And the tangent, defined to be the opposite over the adjacent, which reduces by 6 as 3/4. And there's our trigonometric ratios. Okay, we now go to this example. Now notice the figure has been turned. This is the hypotenuse right here. So look for angle z. What side's opposite z? The 9. What's the hypotenuse? The 15. And then divide by your 3's. And you get 3/5. The cosine. There's z. Now what side is adjacent to z? It's this one. It's touching it, right next to it. So it's 12 divided by the hypotenuse of 15, which is divisible by 3. 4 goes into 12, 3 goes into 12, 4, 3 goes into 15, 5. Tangent of z is the opposite, 9, divided by the adjacent, 12, which reduces by 3's to 3/4. So there's our 3 trigonometric ratios. Okay, continuing. This one. Now notice it's twisted again. There's the right angle. That's the hypotenuse. So we go to angle C. What's the opposite? 40. What's the hypotenuse? 50. And we reduce by 10s, 4/5. Cosine. There's C. What side is touching C? It's this one. Divided by the hypotenuse, 50. And we reduce by 10s, 3/5. And the tangent. What side's opposite? 40. What side's adjacent? 30. And we get 4/3. And there's our trigonometric ratios. Okay, next example. We get a little different set of numbers. There's your hypotenuse. Okay, the sine is the opposite over the hypotenuse, and it will not reduce. The cosine is the adjacent, 35, over the hypotenuse, 37. Once again, it will not reduce. And the last one, tangent. The tangent is the opposite divided by the adjacent, and that will not reduce. So there's our 3 trigonometric ratios. And our last example, so let's just make sure we have it. Notice this is the hypotenuse. So we put our finger on Z, and what side's opposite? 12 over the hypotenuse, 37. And it will not reduce, just like the previous example. The cosine of Z. What side's adjacent? This one's touching it. Over the hypotenuse. And our last one is the tangent. The tangent is the opposite divided by the adjacent. And once again, it will not reduce. So you see some similarities. The amazing thing is any one of these 3 trig functions will find and measure them angles. So you don't have to use all 3 of them. But it's advantageous to know them. Now, we're going to show you how to compute on your calculator 2 examples. Okay, now if you have a calculator, fine. But with the idea that you can access them off the internet, some have them on their phones, most of you can find this. Notice that we're talking about the sine, which we just introduced, and the cosine. So this is degree symbol. But there's other ways to measure an angle. There's a radian. And by default, the calculators go on radian mode. So if you don't change the mode to degrees, you're going to make mistakes. So the first thing you need to do is go to the word mode on your calculator and switch it to the word degree. Degree. Okay, just to make sure. I'm looking at a TI-84, which you can find online if you don't have one. There's the word mode. And the third line has a word called radian. You'll be introduced to that later. You scroll over and hit degree and enter. Now it's in degree mode. Okay, then you go to your home screen, second mode. And I want you to look for the key sine. The sine key is SIN. Right there. Hit sine, and then type in 48. Close your parentheses and hit enter. You will have about approximately 0.743, etc. If you have that, you did it correct. The second one is the cosine. So you look for the key right next to sine, cosine. hit cosine of 61, close your parentheses and hit enter. And if you have about 0.484, then you're correct. So we will be using this once we master the concept of trigonometric ratios. Now, I have extra for experts. So some thought questions. Let's look over here and let's expand our minds a little bit on this one. Question 1. Can the sine of an angle be equal to 2? Can a sine of an angle ever be 2? We could have used other numbers. We could have used numbers, any number greater than 1 in place of 2. So to look at this, I want you to look at the way we drew this triangle. So we have a right triangle. Shape it however you like. And just take one of the angles. Let's call it A. Now, the sine of A is defined to be the opposite over the hypotenuse. Well, what's the largest side? What's bigger? Is the opposite bigger or is the hypotenuse bigger? I think you'll agree. The hypotenuse is the bigger side. Every time. So if you were to divide two numbers, number x by number y, and y's larger, for example, 4 over 5, 3 over 5, 8 over 10, you will see this number will never be 2. In fact, it's always going to be less than 1 because this is the largest side. So example, we did numerous ones. If this were side 4 and this were side 3, this would be 5, and the sine of the angle would be 4 over 5. So since the hypotenuse is the largest side, you can never divide and get a number bigger than 1. It's impossible. So the answer to this is no, because the hypotenuse will always be larger than the opposite. If not, it wouldn't be a triangle. I hope that was clear. Now the last one is an introduction to what we'll see soon. I give you that the sine of an angle is 1 over 3, and I ask you to find the cosine. So let's draw a triangle. Now I'd like for you to draw the triangle out as neat as possible. And let's call this the angle X. Now what's the sine defined to be? The opposite, which is 1 over the hypotenuse, which is 3. Sine, opposite over the hypotenuse. Now, we can find this side by the Pythagorean theorem. Let's call it y. We know leg squared plus leg squared is hypotenuse squared. We know that. 1 plus y squared is 9. Subtract 1 and we get y squared is 8. and then we take the square root of both sides, and we have the square root of 8. Which breaks down to the square root of 4, square root of 2, which simplifies to 2 roots of 2. Hopefully you have learned that. So this side y is now going to be 2 square roots of 2. So in closing, what's the cosine of x? The cosine of x is the adjacent divided by the hypotenuse. And that's your answer. Our next lesson will deal with finding more problems such as this. And this was our extra for experts today, which I know you are. So anyway, I hope this was informative, and hopefully I can find somewhere to get a haircut eventually. Take care.